Now, preventing exposure to chlorine is the best way to protect health. Options that should be considered include the following, listed in order of preference. First, use of less hazardous substitutes. Then, use of engineering controls. Use of administrative controls to implement changes in work practices in order to reduce exposure. And lastly, use of PPE. Let's discuss each option in detail. One option to control exposure to chlorine is to use other chemicals when practicable. For cases where chlorine is added to water for sanitation or treatment, there are a number of options. Some examples include use of chlorine compounds such as sodium hypochlorite instead of chlorine gas. Use of copper or silver electrodes, where copper is used to control algae and silver will control bacteria. Or use of UV generators for sterilization and water treatment. In the pulp and paper industry, the use of chlorine for bleaching pulp creates dioxin as a byproduct. A very nasty stuff. In these instances, the use of chlorine dioxides or ozone as a substitute for chlorine does not produce this byproduct. There are also a number of chlorine-free alternatives for cleaners and disinfectants. As discussed in a previous video, engineering controls are processes used to eliminate exposure to a substance. Engineering controls remove the substance from the air or provide a barrier between the worker and the substance. Examples of engineering controls that can be used to prevent exposure to chlorine include installation of local ventilation hoods, use of general ventilation, enclosures around work processes such as fume hoods or glove boxes, use of automatic systems to transfer chlorine gas from storage containers to process containers, and good design of buildings, plants, and facilities where chlorine is used, manufactured, handled, or stored to control and prevent exposure. Now, it is important to pay attention here to the following point. Where ventilation systems are used at the workplace, they must be properly designed and must not vent back into the work area. If engineering controls are working properly, they will eliminate or greatly reduce the potential hazard. They only need to be installed once and do not place a physical burden on workers. However, an initial investment is required and the systems must be properly operated and maintained once installed. Now, work practices that can be used in the workplace to reduce exposure to chlorine include educating workers about the hazards of chlorine, so workers must participate in training and monitoring programs in the workplace. Using good hygiene practices, workers must not eat, drink, or use tobacco products in areas where chlorine or products containing chlorine are used or stored. The hands and face should be washed before eating, drinking, or smoking. Using and maintaining engineering controls and other equipment to reduce exposure properly. Installation and use of an alarm system to warn of chlorine leaks. Ensuring that unprotected workers are not in areas where products containing chlorine are used. And cleanup of spills quickly and properly using appropriate protective equipment and clothing. Now, it is true that implementing work practices to reduce exposure are often less expensive than other control measures. However, workers must be properly trained and use the safe work practices, and managers and supervisors must monitor this in the workplace. In addition, if chlorine is used in the workplace, the employer must develop written procedures to cover normal operations and also emergencies. These procedures must include details on the proper operation and maintenance of workplace controls and alarms, as well as protective equipment to be used by workers. In general, the storage room for chlorine should have a sign warning that chlorine is present. Respiratory protection is required and that access is restricted to authorized personnel. The door should be locked when no one is in the room. Chlorine cylinder changes should be done, if possible, when there are no workers or members of the public in the building. The ventilation system in the chlorine storage room should be on and functional when workers are in the room. In addition, a chlorine alarm system should be installed with an indicator located outside the room. Workers must wear appropriate protective clothing and respirators when changing cylinders or handling chlorine compounds. Emergency procedures for dealing with leaks and spills must be developed. The table shown now on screen is a typical example of such a procedure and highlights the protective equipment to be used based on the situation and chlorine levels. Keep in mind, nothing but chlorine cylinders should be stored in a chlorine storage room. Compounds containing chlorine should not be stored with other chemicals. In addition, care must be taken when mixing chlorine or other compounds containing chlorine with other chemicals. In this regard, a chlorine gas release occurred at a chemical facility a couple of years ago when sodium hypochlorite was inadvertently mixed with sulfuric acid, resulting in a chlorine gas release. The chlorine gas cloud generated by the chemical reaction led to shelter-in-place order for thousands of residents. At least 100 employees and members of the public sought medical attention. More about this in the accident section of the course.